Welcome back to ArmanisMath. Today we're going to focus on the nth root exponents and use them to simplify expressions and solve equations. Give me one word from the objective. In the chat, in the live stream comments, or on your screens, I see root, I see can, I see I, exponents, simplify. Okay, that's what we're going to do. So first thing first, I will share another screen with you, and that's this one here. And in this one, I wanted you to basically, we're going to review the last lesson. So start with simple approach here. 5-1, and we said this square root of, let's say, x, this is called common root. There is an index. The index is that little number here, and this also could be written as in an exponent form, exponential form, as x raised to, does anybody remember what was the power here? Does anybody remember the power here? A little bit different. It's not that exactly. I cannot put 2, but I need to put exactly, it's 1/2. Here we go. It's 1, and then remember the root is always at the bottom. It's a denominator here. So it's the denominator. It's 1/2, x to the 1/2. So if I want to say, for example, cubic root, that's going to be the same as x to, because you're saying cubic or third root, that's going to be x to the third. Fourth root, well, you got the drift, right? Fourth root is x to the fourth. So keep that in mind. The exponents is a fraction, a rational, and it's basically the bottom of the fraction here is the actual root that you see on the other side. All right, and then we took basically some examples. We looked at to make this to make this kind of a rule that we need to make sure that it works. So let's try some stuff. So I'm going to say here, for example, I need a square root of 25. Well, all of you, what would be the square root of 25? What do you think the square root of 25 is? Basically 5. What did you do? Well, you took the square root of 25. That means there's two things. One number multiplied by itself twice gives you 25, and that number is basically 5. Okay. Now, why and how did this work on this side here of the exponential? Well, again, it's going to be 25 to the 1/2 power. Then you have to think to yourself, what is 25 to 1/2? How do you do that? Well, 25 to the 1/2 is basically, if I want to break down it to its base, so I'm going to think of it as a base raised to a power. I'm going to say this is 5 raised to the second power. That's 25, isn't it? But the whole thing is raised to the 1/2. And when you see a power raised to another power in parentheses, you basically multiply them out. So I'll do the work here when I say 2 times 1/2. You also could make this 2 a fraction by putting a 1. And then obviously you're going to use your fruit ninja and then chop chop. You end up with 1. So 2 times 1/2 is going to be 1. So basically 5 times 2 times the 1/2 will give you that 5 to the first power, which is a 5. That's why you have the same answer here. Just a sample of why would this property work. It does work. You could go from radical to exponential, and this is just to verify that this is true. Okay, let's do another one. Let's do another one. And this one is going to be, let's do one like with the cubes. Okay, let's do a cube. Let's go with cubic root. A cubic root of 27. Well, okay, 27. Yeah, I know. So a number times itself 3 times gives you 27. What could that number be? That is 3, exactly. And I could just put 3 as the answer, because I know 3 times 3 times 3 is 27. 3 times 3 times 3 is 27. And the root that they're looking for, the root here is 3. It means 3 of the same. You have to have 3 of the same. And we concluded that this is just 3, which is very true. It's like you're grouping 3's together and pulling one of them out. How about here in terms of radical? Well, it's the same thing. Let's take a look. We just showed that a minute ago. So I'm going to put this as 27 raised to what power do you guys think? What's going to be the exponent here? I need more than just few to answer. Here we go. Good job. Over 1/3. And what's the base of the 27? What's a good base for 27 that we could pick here? What's the powers of 3? That's true. 3 to the 3rd is 27. However, there's a person waiting outside here. What about me? What about me? Okay, chill. So 3 times 1/3. So basically you have 3. What about me? What about me? Okay, you got yourself something that is gonna look like this. If you're on the live side, you'll see that I just put something that is very funny. It's from Among Us. Anyways. That's funny. If you saw it, let me know. I just put it. Disappeared second. So 3 to the 3rd, 3 and then times 3rd is basically 3 to the 1st power. 3 to the 1st, which is just 3. So either way, you could definitely get to what you need, and that's just an example of how do you use radicals. Any question on this one before I move on? I am recording today, so you should have it. So take careful notes and definitely have access to it. Any question before I move on? I would like to ask you if you have questions, so we can address it here. Okay, looks like no is the answer. And let's move on to another item, and that is if you have fractions, but this one is going to be a little bit unique because you have actually a exponent that is a fraction. So let's take a look here. Fraction with numbers at the top and the bottom. So what if I said I need 27. Oops, hold on a second. 27 raised to, and I have 2/3. Okay, well, this makes me think a little bit. 27. Okay, so I know that this guy here, the 2/3, if you guys remember, the 2/3 is 2/3. I could rewrite the 2/3 as 1/3 times 2, or 2 times 1/3, doesn't really matter. So the 1/3 I know I could put this guy in terms of radical, a cubic root. I also know that I could do this in just purely exponential. You could solve this in purely exponential, meaning the base and exponent, or you could actually solve this also with radicals. So I'm going to show you two different methods, okay? Two different methods to get to this answer here. The first one, I'm going to use the radical. So I'm going to say this is 27 raised to the 1/3. I need to give myself more room here because that's going to be 1/3. And then the whole thing is raised to the second power. Well, if I looked closely here, it's 27 to the 3rd. I know this. I could write this in radical form, which is the cubic root of 27. I know that, right? Remember, the denominator is actually the root. And then that is raised to the second power. So now, what is the cubic root of 27? What's the number times itself? 3 times gives you 27. Here we go. 3. And I'm not going to forget about this guy who's waiting here. What about me? What about me? Well, okay, hold on. 3 to the second. 3 to the second is how much? Is 9. Okay, you could do it this way, or there's another way. Why are you showing us 2 ways? Well, because there's more than one way. And you need to be able to use both of them in your work and also in your knowledge. You need to know both of them. You might, like, eventually you're probably going to like one more than the other, but you need to be able to go from one to the other. Anyways, so back to the 27. So I'm going to take the 27 and think about, 27. Okay, 27 has a base of 3. So I could say 3 raised to the 3rd power. That's 27, right? And the whole thing is raised to the 2/3. The whole thing is raised to the 2/3. 2/3. Right? All what I did was just found the base for 27, and then I did that. So in my mind now, well, I have a fraction times a number. Basically, I have 3 times 2/3. I could make the 3 a fraction by dividing it by 1. And again, Fruit Ninja, chop, chop, ka-chop, ka-chop. That's going to leave you with 2/1, or just a 2. So now you're going to go here and say 3 to the second power. That's what's left, because I multiplied 3 times 2/3. That's cancel the 3's, left you with 2/1, or just a 2, which means you're talking about the 9. So now I'm going to give you a quick poll here. Tell me which one you like, number 1 or number 2. If you like number 1, give me an A. If you like number 2, give me a B. So go ahead and answer that. I had a feeling that you guys are going to pick that. I don't know why, but maybe because I taught a lot. So I have a feeling that you're going to pick that one. I'm not going to say which one yet, but we're human beings, so we wanted things that are easier, right? That's what we want. We wanted the easier route. So most of you that I will see here, I'm still waiting for 4 of you to participate in the poll, but the majority of you are leaning towards, drum roll, hello, hello. Which one do you think I'm gonna pick? Which one do you think you guys are gonna pick? Come on, I'm still waiting for 3 of you. I'm still waiting for 3 of you. Here we go. 2. It would. What could that number be? Okay. What do you guys think? A number multiplied by itself 5 times, that gives you 32. I apologize for this delay, but okay, focus now. That's the number of times itself 5 times gives you 32. Let me go back to your guys' contribution here and check that out. Since we are in a live session, you need to participate. Yep, that is true. that's 32 raised to the 1/5. That's 1/5. And the whole thing is raised to the second power. Well, I know 1/5 is the 5th root. So that's of 32. A number times itself 5 times gives me 32. And I see some answers here. You guys said it's 2. That is very true, because 2 to the 5th power is 32. Again, it's waiting for another friend outside here, and 2 to the 2nd power is 4. This is for radical. Exponential, you need to know the base. Well, the base here is 2, right? Smallest base is 2 that you could find here. Well, the only base, I should say, in this case. And then, what about base of 4? 4 to the 2nd. What's 4 to the 2nd power? 16 times 4. How about 16 times 4? How much is 16 times 4? Exactly, that's way bigger than 32. So that's why you really have to go to the base, which is in this case just a 2. So 2 to the 5th is 32. But I have a couple friends waiting outside here. 2/5 are waiting for me outside. So I'm going to say this is 5. You do the fraction. You do the work on the side here. 5 times 2/5. And how much would that be, you guys? We did that twice today. How much would that be? 5 times 2/5 is how much? How much is 5 times 2/5? 2, because these two are going to cancel. This one is going to cancel with this one, just leaving you with just a 2. So this is going to be basically a 2 to the 5th, so we just said that's going to 5 times 2/5 is just 2nd power, which is going to be the 4. So it just depends on what you like and what's your flavor. Both should lead you to the same answer, and we actually need to know both. So just keep that in mind. Okay, now we're going to move on to something else, which is the negative exponents. Okay, negative exponents. Okay, negative exponents. What if I have, I'm going to start with a simple one. What if I have 2 to the negative 3? Well, remember that exponents do not really like to be negatives. They do not want to focus on negative in life. They just wanted positive things. So you could give them something negative, but they spin it and give you a positive. For example, they said somebody would say, "Oh, pandemic, and we can't do this." It says, "No, yes, yes, there's a pandemic. Yes, there are challenges, but we could still go through it. I could still do my job. I could still succeed at school. I could still do my best. Even if there's a pandemic or no pandemic, I'm going to do it." And they actually do it. So that's exactly the positive mentality that the exponents have. They don't like negatives. So we're going to give them a sad face here. To be positive, you have to flip the base. Basically, you're going to do the reciprocal of the base. To make this exponent happy, you're going to do the reciprocal of the base. So that 2 becomes 1/2. That's the reciprocal. And now the exponent is pretty happy. It's pretty happy. I'll put a green color here next to it. Okay, so how do you do that? Well, what is 1/2 to the 3rd? Well, that's not really complicated, because you have an exponent here and it belongs to the top and the bottom. Basically, you're saying 1 to the 3rd divided by 2 to the 3rd. Well, 1 to any power is 1, right? So that's going to be a 1, and 2 to the 3rd is 2 times 2 times 2, which is 8. And that's going to give you the answer for this problem. I'm going to do a few of these, okay? Who would like to see more of this? Okay. Let's see, if I have 5 to the negative 2, what do you think I'm going to do here? Can anybody tell me? I'm going to flip the base. Don't forget, you only flip the base. This is pretty sad here. It's going through some hardship in life, but hey, you just do a minor thing and a little thing, and you could see just the light at the end of the tunnel. So yes, we sometimes are lonely because stay-at-home orders and stuff, and but hey, I could find a book, I could phone a friend, I could help my parents, something like that, to make things better. See, now it's better. Look, second power, which means now again 1 to the second divided by 5 to the second. 1 to any power is 1. 5 to the second is 25, and that's the answer. Okay. Now, what if we wanted to challenge ourselves just a little bit more? What if I said I wanted this number here? I'm gonna have 27. Oh, Armani, you're going spicy here. Yep. 27 to the negative 2/3. What? Negative 2/3. Okay. Well, in my mind, I'm sorry, to the negative 3/2 is what I meant. 3/2. Negative 3/2. In my mind, I know there's something that's going to happen with the negative, right? It's not really happy at the moment. And it really wants to participate, but it's not happy. I'm not sure why. Maybe something happened in the family or a tragedy or something. But let's see what's going to happen. I need to flip the base. So it's 1 over 27 raised to that positive base. And the base is now 3/2. Did I say 3/2? I made a mistake, champions. I do apologize. It is the original 2/3. That was my bad, my typo, and I claim it. 2/3 is what we need. 2/3 remains the same. I was thinking of a different 2/3 here because I'm thinking. Anyways, I was thinking of the square root, and I needed the cubic root. This is positive now. So now if I take looked at this here, again, it's 1 over 27. And this 2/3 I could break down, right? I could break down this to 1/3, for example, times 2. That's one way to do it. So it'll be raised to 1/3. This whole thing is raised to 1/3. Okay. Times 2. Well, the 1/3, I know it's the cubic root. So I'm going to say, this problem is going to take a little bit time. So I'm going to say the cubic root of 1 over 27. Remember, the cubic root is actually capturing the entire thing, 1 over 27. The whole thing is under the cubic root. It's a big cube root here. To the second power. So how do you do that? Well, you could break this cubic root to the top and break it to the bottom. So it will be the cubic root of 1, which is 1, divided by the cubic root of 27. Cubic root of 27, and I know that is 3, right? To the second power. So basically, I know it's a 1 divided by 3 to the second power. Remember that 2 belongs, that power here belongs to the top and the bottom. So basically, I'm going to say this is 1 to the second power. I'm being very slow here on purpose because I wanted you to see the details. Obviously, we don't go that slow when we do the problems in the next ones. 1 over 9. Let me recap this one. Okay, I'm going to go over this again. Well, initially I thought this is not the well, now this is the correct exponent. This is negative. This is 27 raised to 27 raised to the negative 2/3. Well, obviously the exponent is unhappy. I make it happy by making the base, flipping the base or getting the reciprocal of the base. So that becomes different things. The fraction 1 over 2 times 2. I'm sorry, 1 over 3. 1/3 to me is the cubic root. So it's the cubic root of the entire fraction here, all raised to the second power. I split the cubic root to the top and the bottom, and I found out that the cubic root of 1 is 1, cubic root of 27 is 3, but I still have the 2 waiting for me outside. The 2 is going to belong to the top and to the bottom, and that's why we end up with 1 over 9. Okay. Okay. We're going to do one more, okay? I'm going to do one more. Let's do, where is the negative? That's what, let me share with you what I'm talking about here. This one's going to be negative 16 raised to the 3/4. Okay, well, I know in my mind there is a base here and there is a negative outside here. Okay, the negative outside I really can't do anything about. This one's just going to drop the way it is. There's no way for me to deal with this at the moment. Just leave it the way it is. Inside the parentheses, however, there's multiple ways. You either could do the radical or you could do, again, the exponential. So I'm gonna go in this case, I'm gonna go radical. So I'm gonna say 16. And what kind of root do you think I'm gonna have here? What kind of root I'm gonna have here? Can somebody tell me? What's the root I'm going to have here? Second, fifth, ninth root? What's the root here? Yep, that is very true. It's a fourth root. Because remember, it's always the bottom. It's the denominator of this fraction. And the whole thing is raised to the second power. So what is the number that is multiplied by itself? 4 times, that gives you 16. What could this number be? What could that number be? True. 2 to the 3rd. Remember, this negative stays here. That doesn't move. And negative, what's 2 to the 3rd? What is 2 to the 3rd? That's true. Negative 8. So remember, because the negative was outside, I just have to wait for it until the end of the problem and then just make sure to include it in my answer. I also could do this one again in exponential. You could do this in exponential. So the only thing that's we're just introducing is just a negative outside, and that's why you just have to keep it outside. So it's negative, this whole number, negative. And I'm gonna break. I'll break, so again, 16 to the 3/4, just like that. So I'm going to keep the negative the way it is. And the 16, I'm going to break it to its component, its base. So the base of 16 is 2 times, to what power? 2 to what power gives you 16? Come on, champions. Share with me. 2 to what power gives you 16? To the 4th. And remember, you have 3/4 here waiting for you. What about me? 3/4. Okay? And we know the secret by now. Right? You know the secret by now that you have this number here times the fraction. And we're basically gonna multiply the number times the fraction. like 4 times 3/4. Okay, and let's do that right now. I'm gonna say this is negative 2 to the 4. So basically, I'm gonna doodle my work on the side here. I'm gonna say this is 4 times 3/4. Remember, there's 2 different numbers here. So 4, and then I'm going to make the 4 a fraction. 4 divided by 1, I could make it a fraction. And then I'm going to, again, use my fruit ninja. That's going to give me the 3, basically. So 2 to the 3rd. Well, 2 to the 3rd is 8. And there's a negative outside here. So that's a negative 8. A couple ways you could do it, and again, just depends on what you like. Okay, what you like. Oh, there's another secret coming up here. Okay. Let me do some other things that look interesting, and this one is going to be the following. Okay, now we're gonna have a little bit chubbier choices. Chubbier choices. What? Chubbier choices? What does that mean? What that means? You're gonna have bigger. Larger problems. So let's try this one here. What if I have a 5th root? Hello, 5th root of 32. Come on, you guys. Of 32 m to the 15th power. Can you have that? Yeah, why not? Could have an exponent under the radical. So totally fine. So this would be, if I break this down, that will be a 5th root of 32 times the 5th root of m to the 15th. Okay, the 5th root of 32, that's the number multiplied by itself. 5 times gives you 32. What would that number be? Does anybody know? Yes, that is true. That's a 2. And then this one here, I really have to change it to exponential, because I really can't deal with it at the moment, like the way it looks. Well, what I gotta do here is take the m to the 15th, right? And what do you think I'm gonna raise it to what power? What do you think is gonna be the power here if I want to go from radical to exponential? Come on, champions, you know this. Exactly, the 5th power. That's one of the first things that we've done today. So now I'm going to say 15 times 1 over 5. Well, how much is that? You could make the 15 again a fraction. How much would that? How much would that be? Come on, guys. Come on. Come on. Focus. How much would that be? Exactly. It will be 3. So I'm going to go here and say, well, this whole blah, 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 blah. This is actually m to the 3rd. And don't forget there's a 2 here. So that's your answer. Simple as that. So even if the problem is a little bit chubbier, you could break it down to its own component. And from there, you basically deal with a fraction in terms of the radical and then change that to fraction. Okay, let's do another one. Yeah, let's do another one. And this one is going to be, this one is really chubby. Are you ready for this one? Okay. Let's say this is going to be really chubby. If you are on the live, stream, you'll see something right now because it's going to be a okay, something happened. Anyways. Okay, here's what we need to do. This one is chubby, which is fine. We could deal with that. And this one is like really big. So I'm going to go like this. Oh my gosh. I've got 256. What? What? X to the 12th. Y to the 24. Good Lord. And this whole thing has a fourth root. What? So 256. Well, I'm gonna divide and conquer. So I'm gonna say this is fourth root of 256. A number times itself 4 times gives me 256. Try to find out that number, you guys. X to the 12th to the 4th power. I should say, yeah, 4th power. And then again, I have y 24. Somebody try to play with the numbers or find out what's that number that you multiply by itself 4 times gives you 256. That's the number that we're looking for. 4 times. So a number times itself 4 times gives you 256. Well, let's play. 4 times 4. Somebody's suggesting 4. 4 times 4 is how much? Yo. How much is 4 times 16 times 4? 60. Hello? 16 times 4? 64 times 4. So basically I have 60 times 4. That's 2 and 4. Woohoo! My goodness. Who was the first one to claim this number? Rojas. Awesome. Okay, so 4 is the number here. That's what I get from this one here. That's 4. Now this one has a little bit work to do. Just a little bit, not too much. I basically have to do with a fraction and a number. So if I said, well, this one, if you want to write it again, it's going to be x 12 times, what, raised to what power, you guys? Raised to what power here? Come on, you know this by now. Here we go. 1/4. And also the y, 24 raised to what power? It's the power for the hour. Hello. 1/4. That's very true. Okay. So I could deal with that. I mean, I'm going to take one at a time and then think about it. I have basically a 12 times 1/4. And how much would that be? How much would that be? 12 times 1/4. Champions, you could do it. Third, yes, thank you. So chop, you're going to do the fruit ninja, and then you're going to find out yourself that you're looking at this dude here. Excuse me. This dude here. With this here. That's going to give you a 3. So basically to the third. X to the third. X to the third. How about the y? Well, it's 24, Armani, times 1/4. The y? Okay. Who's going to help me out here? 24 and 4. How much would you get? 6. Okay. We'll give it a 6. True. So that would be Mr. Y to the 6th power. So this comes down to 4x cubed y 6. That's the answer for this problem. Okay. That is the answer for this problem. All right. Any questions on this? Any question on this? Do ask questions. Do ask questions. Finally, I'm going to close with this. If there's no question, I'm going to close with this example here. Okay? This example is basically you're trying to solve. Solve means you have to come up with a value for the variable. So, solve the following. And if I have something like, I'm going to do it in different ways. Solve x cubed equals, can somebody multiply 12 times itself? What is 12 times 12? What is 12 times, hello, good, 144. What is 144 times 12? 144 times 12, how much would that be? 1728. Okay, so I have a problem here, which I need to solve. I need to solve for x, obviously. So I could either do the radical, so this will be taking the radical, the cubic root of both sides. So that's going to be either the cubic root, I should say, of x cubed equals the cubic root of the other side as well. 1728. Okay, and I'm gonna separate them here because I have another method to solve. Okay, we could show this one in two different ways. And think with me here, the cubic root of x cubed. Oh, what does that mean, Armani? Well, think. I have a cubic root, which is to the third power. Raised to what power? Does anybody know? I'm going to tell you a secret now, because now you're going to know why do things cancel. Why do they cancel? Okay? And the secret is going to show up. Shh. Nobody needs to know that. Don't tell anybody. The secret is you are raising this to 1/3. Obviously, it is 1/3, right? And if you multiply 1/3 times 3, you're basically going to get 1. You're basically canceling the 3's. That's why the cubic root cancels the cube, and the square root cancels the square, and the fourth root cancels the 4, etc., etc., etc. So that's what you get from this side here. Now the cubic root of 1728, you just told me it's 12. So basically, x is 12. That's the solution for this here. Okay. So that's why the cubic root cancels the x cubed. Now, can you do this in a different way? Yes, of course. We could do this in exponential. On this side, I have x to the third. So you could say the word or here. Or. There's two different ways you could write. And then what is 1728? Well, 1728 has a base of 12. It looks like I'm looking for something that is already here in front of my eyes. Something raised to the third equals 12 raised to the third. Well, that thing that I'm looking for is just basically the x, right? That's the x. So x is going to be 12. So either way you do it, you should be able to land on the same spot. Okay. How are we doing thus far? Good. All right. Right, this should conclude our lesson today. And I will see you guys next time. Don't forget to subscribe, share, and like. These videos are helpful. Then share them with somebody else. I know a lot of people, students, who would benefit from these. Until I see you next time, be blessed. Bye-bye.